All right, everybody. So I'm going to go over an example calculation of what I want to see in your lab. I have magnesium sulfate here, so I'm going to show you how to calculate the molar enthalpy of solution for magnesium sulfate being dissolved in water. Okay, so I have the volume of water here, and I have the amount of magnesium sulfate I'm using right there, and the initial temperature and the final temperature and the delta T calculated. Okay, so we will start by figuring out how much thermal energy was released when magnesium sulfate was dissolved into 100 milliliters of water. So you need the mass of the solution. So the mass of the solution is basically the water and the salt together. So 100 milliliters of water, the density of water is approximately 1 gram per milliliter. So you can say that 100 milliliters is 100 grams. So mass of the solution is going to be 100 grams plus 5 grams. So that's going to be 105 grams. Okay. Um, then what you are going to be calculating is Q for the solution. So we know that Q for the solution is equal to the energy released by the dissolution of the salt in the water. So Q aqueous plus, we have to actually correct for the calorimeter, the amount of energy that was lost to the calorimeter in the process of dissolution. So I actually gave you the, I believe I gave you the specific heat of the calorimeter in the lab handout. So you can, you should be able to calculate QCal. So the Q for the solution is going to be the thermal energy released when the salt dissolved plus the correction for the calorimeter. Okay, so this is what your work should look like. And then this Q of solution is basically the molar heat of solution, because remember, heat is the same as enthalpy in terms of this kind of reaction because we don't have work. So enthalpy and heat are the same thing. Okay, so let's calculate Q for the solution. So that's going to be 105 grams. When you're dissolving something in water and that's your whole reaction, that's your system, okay? That means you have to add both the mass of the water and the salt together to get the total mass of solution, okay? Don't just do it for the 5 grams. So 105 grams of solution. Ooh, I forgot the negative sign. So let's do 105 grams of solution times 4.184 joules per gram degree Celsius. That's going to be our specific heat capacity for the water times my delta T here. Whoops. My delta T here is 7 grams. No, not 7 grams, 7.9 degrees Celsius. The moving around of slides is bothering me. Okay, so this whole term plus I have to now do the correction for the calorimeter. So that's just going to be the specific heat of the calorimeter, which I gave you guys 17 joules per degree Celsius times the 7.9. Okay, times the 7.9 degrees Celsius. Alrighty, so those are the two terms that we are going to add up. All right. I don't know what I did here. What did I do? Oh, all right. Well, I disappeared, but that's okay. You can still hear me. So let's calculate this out. 105 times 4.184 times 7.9 gave me 3,470. 3,470.628 and this is going to be in joules because grams and grams cancel out, degree Celsius cancel out, joules plus I think 134 joules. Okay, um, that will be our total Q for solution. Okay, so that's going to be 3,604.628. So let's go with 0.63 joules. Okay, so that's Q of solution. That's total Q of solution. Now we have to figure out what molar enthalpy of solution is. Molar enthalpy of solution or molar heat of solution is basically per mole how much energy is released. So we're using 5 grams of magnesium sulfate, which means we have to convert the 5 grams of magnesium sulfate to moles of magnesium sulfate. So that'll be 120.39 grams of magnesium sulfate. That's the molar mass. 1 mole over here. So let's see, 5 divided by 120.39 gives me 0.0415 moles of magnesium sulfate. So if I have the number of moles of magnesium sulfate in 5 grams, and I have the total amount of energy that was released by the dissolution of 5 grams of magnesium sulfate, I can figure out molar enthalpy of solution. And that is going to be molar heat of solution is going to be negative 3,604.63 joules divided by actually, I should probably just convert this into kilojoules because molar enthalpy of solution is usually in kilojoules. So you just divide this by 1,000. Okay, and you have 3.6. Do I have the correct number here? Yeah, I do. 3.604. Let's say 3.605. I wonder if I should round 605 kilojoules of energy. So 3.605 kilojoules of energy is the Q for solution. So we take 3.605 kilojoules of energy and we divide it by 0.0415 moles. That should give us kilojoules per mole as our answer. Okay, so 3. Divided by I multiplied by accident 0.0415. That gives me 86.858. So 86.86. 86.86 kilojoules per mole. Now let's see sig figs. I have 2 sig figs in 7.9, so I have to round this to 87 kilojoules per mole. So that means for every negative sign, for every 1 mole of magnesium sulfate, 87 kilojoules of energy is released. Okay, so that is how you calculate molar enthalpy of solution.